In the third experiment, we'll be practicing purification by a method known as recrystallization. In this experiment, we will purify the acetylsalicylic acid that was made in the previous week's experiment. The ASA and all of its impurities are going to have the same safety concerns that they did in the previous experiment. So you should refer back to the PreLab assignment from that experiment to check on the hazards associated with those chemicals. The only new chemical used in this lab is denatured ethanol, and you'll be asked to report on that as part of this week's PreLab assignment. The first step in our recrystallization process is to set up a hot water bath. And to do this, you should set up a metal tripod with a piece of wire mesh on top, and you should set a Bunsen burner underneath it. Then you should fill an 800 milliliter beaker with approximately 400 milliliters of distilled water and set that on top. Begin heating the water and measure the temperature with a thermometer. You want the temperature of the bath to be between 50 and 60 degrees Celsius. If the water starts getting too warm, you can turn off the heat briefly, and if the water starts getting too cold, you can turn the heat up. Once you have your hot water bath set up, you should transfer the crude ASA from the watch glass that you stored it on into a small beaker. You should then add between 10 and 15 milliliters of ethanol from a graduated cylinder. Once the ethanol and ASA are mixed, some of it may dissolve, but most of it probably will not. You'll have to place your beaker into the hot water bath and keep it between 50 and 60 degrees Celsius until all of the solid has dissolved. And remember, you can measure the temperature with your thermometer and adjust the temperature as needed. Once everything is dissolved, you should add 30 to 40 milliliters of warm water to the solution. And because you already have a hot water bath, you can simply pour water from your hot water bath into the beaker. This volume can be fairly approximate and measured using the graduations on the beaker. If a solid starts to precipitate at this point, or the solution starts to look cloudy or greasy, you should continue to warm the mixture in the hot water bath until the dissolution is complete again. Once all the material is fully dissolved, you should remove the beaker from the heat and allow it to cool to nearly room temperature. After the beaker reaches room temperature, you should place the beaker into an ice bath for about 15 minutes. Once the beaker is at or near the temperature of the ice bath, the maximum amount of precipitation should have occurred, and you can remove the beaker from the ice bath. Once you've removed the beaker from the ice bath, you can recover the precipitated crystals using suction filtration. You should do any transfers using cold water because you don't want to reintroduce any impurities from the filtrate. After filtration, continue drawing air through the crystals until they're dry or almost dry, and then weigh your crystals onto a watch glass as we've done in previous experiments. And finally, you should label your crystals with your name and your partner's name because we'll be using these materials in a subsequent lab.